Hello, in this module we are going for accelerated failure time model using R. We will see how to apply accelerated failure time model in survival analysis using R. It is to be noted that one of the widely used tool for survival analysis is Cox proportional hazard model, where it is assumed that proportionality assumptions over follow-up times. The proportionality is multiplied with the covariates under consideration in Cox proportional hazard modeling. But every time it may not be possible to follow the proportionality hazard assumption. When proportionality hazard assumption fails, then as an alternative of Cox proportional hazard model, accelerated failure time model can be used. The nice feature of accelerated failure time model is that one constant value multiplied with the covariates to get the regression coefficients value, where the constant value may be accelerated or decelerated over the time. Parametric modeling can be considered through accelerated failure modeling. Also, parametric distributions like exponential, Weibull, log logistic, gamma can be implemented under the arena of accelerated failure time modeling. In this model, we will illustrate the application of R through accelerated failure modeling. Here we are going for accelerated failure model. We are using R. Learning objective is to how to fit accelerated model failure time model through R. This is the data. On first observation is event that is taken decoded as 1 or 2. So event of interest may be considered as death or relapse after doing the surgery or after giving the treatment. If relapse happen, then it can also be considered as event. Otherwise, death can also be considered as event. So here if 1 is given, then death happen, and 2 denotes that death not happen or even not happen. Same way if is considered as relapse, so 1 is denoted as relapse happen, 2 defined as relapse not happen. Now second variable is OS, standing for overall survival, that is standing to how many days patients observed. Since it's a unity here, duration is the days, so here we have, as illustration purpose, we have considered as 12, 25 days, 21 days, 23 days, 18 days, 26 days. So it can also be converted into months or year based on study to study. Now the third variable is smoking. Again it's categorized into two value, one is 1 and another one is 0. So 1 represent that patients is smoker and 0 represent patient is not smoker. Fourth variable is SBP, standing as systolic blood pressure. So during the first visit, the systolic blood pressure of the patients are considered here. As considered, you can see the first patient's SBP or systolic blood pressure was 65, second one was 88, third one was 80. So all the patient's informations or systolic blood pressure considered and assigned as a SBP here. Now coming to the other variable like BMI. Here BMI stand for body mass index. It is generally assumed that if it is more than 20, then the BMI is quite normal. So here all individuals considered in the studies, BMI is given as 22, 25, 26, 27, like that. next variable is the CHOL. It stands for cholesterol level. So all the individual cholesterol value has been considered here, and here in this slide third variable is drinking. So frequency of drinking has been considered here. Drinking in the sense is alcohol drinker or not, and if it the alcohol drinker and how much considered. So basically it's a four categories has been considered here to mention if the drinking is the mild, moderate or severe, more drinkers or not, like that. So all these variable like event, weight, smoking, SBP, BMI, cholesterol and drinking has been assigned as a function called data.frame, and the whole thing has been assigned as a database called S. So now thereafter we will call the database S, and for in these databases we will call different variable, and applying that database we will apply the accelerated failure time model. As we had earlier mentioned, that accelerated failure time model is applicable when proportional hazard assumption fail. So it is advisable before directly applying to the accelerated failure model, you should check the proportionality assumption is violated or not. The proportionality assumption violated or not can be checked through graphical data explorations and also by testing procedure that we have seen earlier module. I am not going into details in this module about the testing about the proportionality hazard assumption, but it is to be noted that again if you go for applying the accelerated failure time modeling, before that you should check that proportionality hazard assumptions violated or not. If it violated, then we may go for AFT model. Now coming to the model fitting process, here the library HA is considered. Where the function AFT-REG is there. So we will use the function called AFT-REG to proceed with regressions modeling through accelerated failure time modeling. As we had mentioned that AFT is one kind of regression modeling. Now see the enter functions here. We had assigned fit through AFT-REG functions, and into the parenthesis we had mentioned the capital SURV function, and this SURV functions taking care about the OS. So durations is considered here, followed by event. So in earlier module we have seen that follow-up time, follow-up status is considered, but here this is simply overall survival, that is follow-up time is considered, followed to event. Now here is considered as a distributions is a log logistic distributions. Please note that AFT model is a parametric modeling, and there are several options to be considered to run the AFT modeling, AFT regression modeling, like as a distribution of choice. Here we have considered log logistic because this is the one of the widely used distributions because it's a closed form distributions. But not only log logistic regression, there are other choice of distribution like Weibull, exponential, gamma distributions. Since if in a case of study where people are having huge number of days in certain short time being, and after that the death or relapse rate keep on decreasing, in that scenario we may go for Weibull distributions. In other situation when we are having rapidly increase of the death rate over the period of time, then we may go for exponential distributions, but otherwise generally we may go for log logistic distributions as an assumed distribution for our modeling. Now that's fourth line we are putting as a plot of fit. So this plot of fit will give us the what is the output of the functions in a graphical format, and we will get the graphical results to put by the logistic regressions, log logistic distributions. Now we are assigning, now as a first attempt we are assigning that AFT OS on event. Now in place of that second attempt we have tried to consider that AFT-REG serve of OS, event followed by smoking, SBP BMI, cholesterol, drinking. So here we are trying to find out that what the factors are contributing towards survival durations. Let's check that in first model we didn't mention the factors, but in second attempt we try to find out the exploring the factors contributing to the survival of these patients. So here we have as a choice parameter we have considered the like exponential distributions, and after that we are calling the data set that is called data equals to CS, because in earlier slide we have seen is assigned as the database for all variable with weight, event, smoking, SBP, BMI, cholesterol and drinking. Now we go for second slide. This is the results obtained from this study, where the AFT RAG and the result function we have used earlier is coming. Now as a result we can see the covariates listed here are smoking, SBP, BMI, cholesterol and drinking as a first column, and in a second column their weighted mean also assigned. So that is the beauty of the accelerated failure time modeling applications. So it's assigning the each and every individuals the weighted mean here, and the corresponding coefficients obtained as regression coefficients value, estimation of regression coefficients given in the third columns. For smoking you can see that a value is coming 0.071, for SBP coming minus 0.003, for BMI it's coming minus 0.040, and for cholesterol is coming 0.101, and for drinking it's coming 0.001. So, and the corresponding like exponential values and the standard error of coefficients and world p value also coming. Since the p value is showing that none of the factor is having significant contributions or influence on this response of interest. Now this whole overall p value is coming down in the presentation, it's coming 0.34. So you may consider these factors considered here are not really influential factors on this study. So it should be noted that just for as a illustrated example I have considered this data set. In real life scenario the data may be different and the p value can be nicely significant value here. And now I will go for another application of AFT model in next slide. Before that there is a results coming at plot. When you have putting the plot of fit, the values observed from the sample data is given, and you can see the first plot is giving as a y-axis durations and the hazard functions how it's distributed given. Second value, first row, second figure giving as a log logistic cumulative hazard functions. As time keep on increasing, the cumulative hazard also increases. The density as observed from this data set also given in this second row first column graphs, and the fourth graph is given this log logistic functions distributions here. Now another package is there that is called OYServe. So initially we had used the library called EHA. Now we are using OYServe function library to get again the AFT modeling, where stage is first variable is considered as disease stage or progression stage can be considered. Here we are having 4 choice to define the stage 1, 2, 3, 4. So all individuals having either 1, 2, 3 or 4. Any observations, any stage is there. Follow-up time of all individuals are considered as time and assigned as 2.3, 3.2, 3.6 like that. So all individuals time observation measurement also considered here. Now coming to third variable, this is to be mentioned, this is another database, not the database earlier we have used. This is database we are using to illustrate this application of AFT through the library called YSURV. Now the age also considered, and delta stand for disease presence or absent to define it. So disease death presence, death present or absent, so death happen or not, that defined as delta. So if delta is 1, that's mean death happen. If delta is 0, that's mean death not happen to those individuals. Now the whole variable like 4 variables, stage, time, age and delta assigned through a function called data.frame and as a database chemo trial, and when we are calling the chemo trial as a attach of chemo trial, and this attach of chemo trial, after that we are calling serve reg. Into serve reg we are putting serve of time and delta as factor of stage, and as a choice of distributions we are using variable. In addition to this, another factor that is called age. So next slide we will see what is the results coming for serve fit, and this result of whole analysis result of serve fit can be called as summary of serve fit. Now coming to another choice distribution choice. Here since we don't know how the data distribution is fitted, so as a natural choice we are initially considered as variable distributions. The same variables and with time and delta has been altered with the choice of distribution as exponential, and again serve fit of exponential has been called, and the results observed of the covariates regressions observed by applying the serve fit exp are called as serve fit exc with coefficients. The intercept and scale coefficients given as serve fit exp with I coefficients. It is to be noted that in survival analysis, since we are considered the observation, so during the follow-up observations, so it is very important to consider the variance covariance matrix also. So serve fit exp with var will give us the variance covariance matrix, and the log likelihood will give us the how the model is suitable or how model is fitted here, and with the scale values can be obtained with serve fit given scale value. Now in next slides we will see the results obtained from these data. Now this is the result for serve fit exp, and when we are putting serve fit exp value of the all regressions coefficients coming, here to be noted that as factor of stage 2 having influence on overall survival, and it since it's coming with negative value, so those having more stage 2 they are having less survival, and it is observed with highly significant p value. Again stage 3 is coming also coming negative value, but in comparison to stage 2 it's having less negative value. It can also stated that those patients are having more stage 3 value, they are also having less survival durations. The same thing happened for stage 4 also, and it is to be noted that stage 4 is coming more significantly, and state also those patients are having more stage 4 value, they are having less survival duration. So as stage keep on increasing, survival also keep on decreasing here. Now I am coming another factor, that is age also stating that it is having significance role, and age increases survival duration will decrease. As a choice of distributions we don't know what is our data following, but as a choice we assume that it is following exponential. In real life data may follow exponential, may follow variable, may follow gamma. So before applying we have to explore the data, what kind of data distribution is there, and based on that we have to take decision to apply assumed distributions. So as a illustration purpose I am not doing that work, but it is to be advised that before consider any distributions through data explorations, check the type of distribution present in your sample data. Now coming to this example with the variable, the same results are coming here with the different assumption of the distributions, and again with scale matrix that is coming with 0.44, and for also the intercept it is coming 2.34 with p value. It's highly significant as stage 2, as stage 3 and stage 4 negative regressions value coming, and corresponding p value also coming significant. So we may consider here. It is to be noted that in earlier cases p value was 0.34, but here it is coming 0.66. So in comparison to the earlier model, this model should not be considered if your p value, overall p value coming more. Now coming to this, how to get the intercept and scale coefficients value. If you put the serve fit of x with I coef, it will give you the intercept and log scale value. Variance covariance matrix for different stage with different stage and can be observed since we are having stage as categorized as factorized as a 2, 3 and 4. So in addition to this reference category, that is 1, so with respect to, say, first column here is showing the intercept, and after that as dot factors of stage 2, after that as dot factor stage 3, as dot factor a stage 4. So since we are having 4 stage 1, 2, 3, 4, whatever results is coming here is basically with reference to stage 1. So it is to be noted that the variance covariance matrix of stage 2 with respect to stage 1 is coming minus 0.08. Again, stage 3 with respect to stage 1 is coming minus 0.06, and stage 4 with respect to stage 1 is coming minus 0.04, and for age also it is coming minus 0.002. So this way this factor covariance and variance matrix can be obtained here, and the log live that is most useful to find out the model suitability also comes as negative value always, and here it is coming as minus 205.82 to minus 204.63. The scale matrix here is obtained as 0.44. This is the results of the. Thank you. In this model we have seen how to apply accelerated failure time modeling in R. Here we have used two library, one is library EHA and another one library YSURV. We had given two example dataset and interpretations and statistical inference to be considered from this example dataset. I think this kind of example can help you for further work on survival analysis where accelerated failure time model is suitable.